In this video, we're going to talk about making use of the crane element in AnyLogic, but using it in a more flexible way. So we already know that in the crane element in AnyLogic, the crane has a specific path or runway that it can move along. However, if you want this movement to be more flexible, so for example, let's assume that we want the crane to move along an arc or anything else, it is not directly possible using the crane element as it is. So we need to do some manipulation in order to be able to do that. The easiest way to do this, and probably the first thing that would come to your mind, is to use the crane as an agent. And this is actually the approach that we will be using here. However, there are certain tricks that we need to do in order to be able to successfully use the crane to move the needed agents. So I prepared this very simple model. So here I have two agent types or two agent populations, which is the crane, and the other one is the boxes, which are the agents that are going to be moved by the crane. One small note, since we are going to use the crane as an agent, so in other words, this means that we will put the crane element inside the agent type crane. So one small note, do not call your agent type crane, because this name is already used by AnyLogic for the specific crane, and this is why this might cause problems. So that's why you can call it anything else. So that's why I called it crane agents. So the actual crane element that is found in the material handling library in AnyLogic, the overhead crane, this is the element that we usually use. So what we are going to do is to drag this element inside the agent type crane agent. So that's how we convert the crane into an agent that we can use more freely to move around. So this process simply generates the boxes and distributes them over these attractors in this area and in this area. And here, when the box leaves the process through the exit, it will go through the process that exists inside the crane agent here. So this again is a very simple process. So all we are doing here is that we are making the crane move towards the box to pick it up and then take it to another place. So let's try to run the model now and see what happens. Okay, so as you can see here, the boxes are being generated, so we can speed this up. Now I have this button, and what this button is going to do is that it's going to free one of these boxes. So as you can see that we are getting an error indicating that the box and the crane have different spaces. So this is the first problem you can face while doing this. And so there is a small trick that we can do in order to overcome this problem. So what we can deduce from this error that we got is simply that the crane element as an element and the item or the agent that it's going to pick up, they have to be both in the same agent or agent type. So that's why this means that the population that the boxes exist in when the crane needs to pick it up have to be here with the crane. What we are going to do is that we are going to add a population here, and we are going to move our boxes from the population in the main to the population here whenever we need to pick up a box. So as you can see, we add a population of boxes here inside the crane agent. Of course, it's of type box. And once the agent needs to be picked up by the crane, what we will do is that we will make it go to this population. So it will change populations from the one in the main. So when the box is generated, it goes to the box's population here in the main. And here, what we are doing is that we are making it change populations from the one in the main to the one here and the crane agent. So let's try to run the model now as it is and see what will happen. So when we press the button, in order for the box to leave this process, as you can see, the box that was here changes position to here. Okay, but this is not what we want. And this happens simply because when we change the population from the one here in the main to the one in the crane, the position or the location of the box will be at the 0, 0, 0 of the crane itself. So this is the second issue that we need to take care of in order for the expected result to happen. So we have the crane here. It has a certain X and Y on the main. And we also have the box that also has a certain x and y in the main. However, when we move this box into the population inside the crane, its x and y are going to be 0 relevant to the crane. So what we need to do is to find the x and y of the box relevant to the position of the crane. So how do we do that? Simply, in this situation, for example, what we can do is the x of the box minus the x of the crane, and the same for the y. So the y of the box minus the y of the crane. So this way we find the new coordinates of the box that we should locate the box when we transform it to the population that is inside the crate. However, there is something else that we have to be careful about, and that is the scale. So if the scale of the agent in which the population of boxes is in is different than the scale of the crane agent, then we cannot simply do the conversion without using the scale. So here, before moving the agent to the new population that is here in the train agent, what we need to find first is the new x that we are going to use, which is the x of the agent minus the x of this crane, as we said, and the same for the y. However, in order to take care of the scale, we have to do one additional step. So the first thing that we are going to do is to convert the x that we found into a length unit using the scale in the main. So this is what we do here. Any length unit works, so I used meters in this case. And then finally, we use this value that we found that we have in meters now to convert it to pixels, but this time in the scale of this specific agent. That's why we use this to pixels. So here we use main to length units, which means that we will use the scale of the main, and we use this to pixels, which means that we will use the scale of the crane agent. And this finally gives us the x that we need for the box, but in the scale of the crane agent. And of course, we do the same thing for the y. And if for any reason the object that we are moving has a certain z, so we will need to do the same thing for the z. But here, because the z is 0, it doesn't really matter. So following that, we change the population of the agent, and finally we set its x, y, z to the new values that we calculated here, and z is equal to 0. So here we are using the seize crane, which will make the crane move towards the agent so that it can pick it up. Let's see how this happens. Okay, I have added a 3D view just to see what's going on. And now the crane should start moving in order to pick up the agent. Remember that previously the box moves towards the crane, but now, as you can see, it didn't change its position because we made sure that we correct its position. And now the crane will successfully pick up the box. So that's it. We see it working now. Now, to continue, what we need to do next is that after seizing the crane and making it come to the agent and picking it up, we need to make it move to the final destination in which we want to send the box. Now, to specify where the crane has to take the box, we have to do the same conversion in coordinates that we did with the location of the box. Because if we, for example, need to move the box that was here, we need to move it to this node, for example. This means that the coordinates of the node have to be given to the crane and the coordinates relative to the crane agent that the crane is in. So here again, we are going to do exactly the same conversion. So we just choose the node in which we are going to take the box to, and then we do the exact same steps, but instead of doing agent.x minus getx, we just use n, which is the node that we need to take the box to. So n.x minus getx and n.gety minus gety, and that's it. But here, of course, we're not going to change the population. Instead, we are going to save these values in the agent because we need to use them here, because we need to specify for the crane that this is the destination that you need to go to, which is this x and y, and of course here z equal to 0. So let's see this quickly. So the crane is going to move to pick up the box, and it should come to put it in this node. So let's see that. Okay, so it picked it up, and now it's heading towards the node. Okay, now imagine that the box that we just moved to this node has now to be moved to a final location, for example, this location, by a forklift. So, of course, what we would need to do is make it leave this process and go to this process in which it will seize a forklift and it will be moved to this node. So let's try to run the model and see what happens based on this. So the crane has picked up the box and now it's going to drop it here in this node. And we expect now forklift to come to pick up the box and to take it to this node. So as you can see, the forklift has indeed started moving, but we can see that it's heading in the wrong direction. So it's not really going towards the box. See? It's going here somewhere, and then it's going back as if it's taking back the box to a certain location. So of course, this is happening because the box and the forklift are not in the same agent. So again, here, what we need to do is to put our box back and the population in the main for the forklift to correctly be able to move it to its final location. So here, after the crane has moved the box, we will simply send our agent back to the population, which is in the main. And of course, we have to remember to set its XYZ. And in this case, we simply set it equals to the XYZ of the element that it's going to or that it has reached, since this element is already in the main, so there is no need to do any conversion. So let's see now, after we do these two simple steps, how things will end up. So the crane drops the box now. The forklift starts moving, but this time it moves towards the correct direction, which is the box, and it takes it towards its final destination, which is this. So as you can see now, everything is working properly since our box is back in the population inside the main. Now remember that the whole point out of this was having enough flexibility to move the crane however we want, not just on the path that it has defined in the crane element. So let's try to do that. So what we are going to do now is that we are going to move this crane towards this point in order for the crane to be able to pick up one of these boxes. So this is as if we have two areas in which the crane can function. When it finishes whatever it's doing in the first area, it needs to move to the second area to function in the second area. So let's try to do that. Let's try to move the crane and see what happens now. So as you can see, the crane is currently moving to locate itself at this point. So the center of the crane was here, remember, which is this edge, and now it's moving towards this point. But what we can see now is that it rotated itself in order to be able to reach this point, and this is something that we don't want. In order to avoid that, we need to set the horizontal rotation of the crane to false because we don't want it to rotate when it moves. So simply here in the button, we set the automatic horizontal rotation to false, and this will allow the crane to move without rotation. So let's see how it will move in that case. And as you can see now, it is moving towards the point here. It moves towards it without rotating. So now what we need to do is that we need to make the crane move again to pick up one of these boxes and put it inside this crane. So again, let's speed it up and see how it will go towards a box, pick it up and put it in this node. So this movement from one area to the other, this is something that we cannot do by simply using the crane element alone. But when using it as an agent, we have the flexibility to move it however we want. Of course, this is a very simple example, and it can be expanded to much more complicated scenarios and much more complicated movements and actions. But these are the main things that you need to know. So the first thing is that we need to change the population of the agents. The second thing is that we need to be careful about changing the coordinates of the agent when we change the population. And the third thing is that we need to be careful about the scale between the agents because both agents do not necessarily have the same scale. Now, up till this point, we have been using the runway of the crane when it needs to move from one point to the other. However, this is something that we might not be able to do if the movements of the crane need to be more complicated. So I will give you a very simple example. So in this case, I'm going to move the crane initially from the point in which it is towards this node. So let's see what happens in that case. As we can see now, the crane is moving to locate its center at this node. Okay, so let's see now if we wanted to pick up the box here, what will happen? So this is the button. So obviously this is going to give us an error. Why? Because now the box is not accessible to the crane because the runway of the crane is currently to the right while the box is here inside this node. So this is an example where using the runway might not be the best choice. So here what we can do is control the movement of the crane ourselves instead of using the move by crane block that is relevant to the crane agent. So we will still need to use these blocks so that the crane actually picks up the object, which is the main functionality of the crane that we will still need. I will show you next a very simple example of how to do that. So I'm not going to go into too much details about how the model is built because it's easy to do. It's just a normal movement of the crane. So here I added this process which controls the movement of the crane. The idea here is that every time the crane moves to the point in which the box is located. So for example, here I'm making it move to this specific node that is at the same level of the box that has to be picked up. So this is the main idea. The main idea is that the crane has to be moved to a point that has, in our case, for example, it has to have the same x coordinate as the agent that has to be picked up. So whenever the crane does that movement, it reaches that point. This is where it will free the agent or the box that will be waiting here. And then the box will leave and continue to the process inside the crane agent. And from there on, it's very similar. So we use the move by crane and the same process. So we have to calculate the new coordinates. We have to move the box from one population to the other. So exactly the same way as we did before, but the only difference is that we are moving the crane ourselves as an agent. So we move it first to this point, which is a point next to the box that we want to pick. And then we move it here towards this point, which is also next to the location in which we want to put the box. You just have to be careful about where you are going to do the conversion and the coordinates and the populations, and that's it. Everything else is very similar to what we did before. So as you can see, the crane moves towards this point. And since the point is at the same level of the box that the crane needs to move, then we have no problem. I'll speed it up a little bit. So as you can see, it picks it up. Okay, and then it moves to this point in order to put the box in this red point. So again, we are moving it to a point that should have the same x coordinates as the position in which the box should be put in. So this way we have full control over the movement of the crane, and we only use the move by crane blocks in order to make the crane use the hook and pick up the agent or the object, or drop it. So just to pick up and to drop. But everything in between, all the movements are controlled by the process that we create.